Hello, good evening. Hello there, good evening.
Yes, good evening.
Yes, thank you there. Is it Festus?
Yeah, it's Festus.
Oh, Festus, karibu sana. I think Festus
Asante
is
sana.
one of our, yes, Festus is one of our technical guys at Marshall. So thank you for joining
Mm,
us today.
mm.
We can only have like two students who have joined today, but I think we just proceed. Yes, so Alfred, hello, Edwin.
Yes, Eric, did you just call me?
Hello.
Yes, I called you. How are you doing?
Hi,
Fine.
I'm fine.
Okay. Welcome to the class, Edwin, Alfred, and today you also have Festus. So I think I'll give him a chance maybe to introduce himself better because he's actually one of our technical guys at Marshall. So Festus, maybe you can say a word or two, and we proceed.
Okay, thank you. Let me start by saying hi. So my name is Festus. I'm a software engineer as well as and with expertise in AI engineering. And I'm joining this session because one of these days I'll be joining Eric to help with tutoring. Yeah, so that's me. I'm joining today so that I can get to understand how you guys are able to learn, so that at some point I may chip in and help.
Thank you so much, Festus. So yeah, just like Festus has mentioned, he will be part of the technical team, and as you can see, we've started on development, so at least we need a hand. And I think Festus is very good in AI development. He has built a couple of applications concerning AI, and it will be very nice to have him on board. So let's proceed with our objective. So before I proceed, I have an outline. I had prepared this outline so that we see what to expect as we are moving on with the sessions. And then from there, now we are going to discuss our today's business, which is retrieval augmented generation. So today we want to talk about RAG systems. Okay, so this will be our main objective today. But before we even start, it's good we know what we are going to cover in our later, like for this month, actually. So I have an outline. I think I had already shared with you, the group. So it's good you have it because it gives you the clear roadmap of what to expect. So this outline is now starting from now the development, and that's why we are also inviting investors to be part of the technical team. So for you to be very well versed with the outline, you should have first installed Olama, which I'm going to ask. If anyone got a challenge installing Olama and Llama 3.2 model, anyone who got a challenge with the installation, that is, anyone who got a challenge with installation, especially Olama models, this one here. And like we had mentioned, Olama is a software that allows us to run large language models locally on our computers without minding about the costs, implications, and also internet. So you should be having this Olama because with Olama, you're able to access several models without minding about the costs. And based on this one, we were able to pull Llama 3.2. So this is a requirement. Still, because you are using Python, remember you can also build with other programming languages like Java and TypeScript. But specifically for this one, I want to ensure you have installed Python and then you have completed the RAG, which we are going to do today. So our today's session gives the foundation for this roadmap. And then you are very familiar now with working on a terminal or a command prompt. Remember, we've been working on a terminal as we were installing some libraries. This is mine. We used a terminal to install Olama, I think. Just start from the word go. So on this terminal, we pulled Llama 3.2. Same on this terminal, we were able to test whether our Llama 3.2 model was running on Llama. And then still on the terminal, we're able to install packages that you need to build these softwares and so much more. So these are requirements that at least you work with a terminal so that as we'll be installing more packages, you are well versed with how to do that one on a terminal, or if you're working on a Windows, we normally use the Windows PowerShell, okay? Some people refer to it as a command prompt. So that is a requirement. And then finally, because we will be pulling some models, similarly today we want to pull an embedding model. So you need a space within your computer system. I would highly recommend at least 10 GB, or worse, we can talk about 8 GB free disk space in your machine so that we're able to even pull out more models and some vector database, as we're going to see. So this is our outline. It's a 4-week outline, so which means that it is going to cover a month from now. So after today, we've tackled retrieval augmented generation. This is what we're going to cover today. One disadvantage that we're going to notice is that this model that we're building today can only handle a single document. That is what we're going to do. So you're going to give it a single document, then that document can be indexed in our system, and then based on that document, we're able to retrieve and generate contents that are based on that document. So this is the foundation session. That's why I'm saying it's a foundation for the outline that we have. Now, after we've done that one today, this outline now takes over from there in such a way that can you have a multi-document RAG system? And not only that one, can you add conversational memory so that it can remember your previous conversations? It can remember your previous conversations. Okay, sorry. So that is, I think I've explained what you're going to learn there in such a way that you can scale the number of documents or the number of knowledge, the knowledge base that you have. Yeah, sorry for that one. So you are able to expand the knowledge base to several documents. Now, in the next phase, as you are working with this document, sometimes this AI system hallucinates. So if you're saying they hallucinate, provide responses that were not there in the document, okay? So how do you ensure that we don't have RAG systems that hallucinate? So you want to ensure that this RAG system answers faithfulness in such a way that the content they are generating are solely based on the document, especially if you're intending to work on document in finance and medical or even governance, because if you're working on these kind of industries, then you need to work with facts, and we don't want to have AI systems that hallucinates while giving the responses. And now that will be giving us a very good foundation in such a way that now can we connect RAG systems to our SQL databases? So one thing you're going to notice as an AI engineer is that most people on the industry now, instead of working not only with PDF documents, sometimes their information are stored on databases. Okay? Like MySQL or Postgres. And most of their employees sometimes work on spreadsheets or Excel sheets. So is there a way we can connect the RAG system to more knowledge base in our databases and spreadsheets? So in such a way that now the non-technical users can just query with a plain English and get responses from databases without SQL. This will be very, very useful, especially for those people who are data analysts, because data analysts are able to get information from databases, but they have to write an SQL query. So we want to avoid that one in such a way that we can also get information from our databases, but with a plain English, so long as now we are fetching that data using a RAG system. And this could apply to those people who are data analysts, especially those people who are working on energy. You want to query information and governance. And now, up to here, all our responses, you're going to notice that all the responses that we've been getting them on a terminal, which doesn't look very professional. This one here. So this is where we've been having our responses, like for the previous class. So now we want to advance from here in such a way that we are able to build a very simple user interface using Streamlit. So Streamlit is a Python library that is used to build AI-powered user interface. So you can just search here, Streamlit. You want to get to know it. So Streamlit. So it is actually a library that is used to build very, very beautiful user interface on our AI application, so that now we limit getting responses on a terminal. That is what you're talking about. So you want to limit getting this is what I'm talking about. So you want to limit getting our responses on a terminal, but rather on web application that has a user interface. So the best one you can start with for now is Streamlit, because it is browser-based, so you don't have to install anything. And then it is very, very well compatible with Python. And now then from there, as we'll be advancing on this AI series, we can now talk about more user interfaces like React and Angular. And then finally, there's something we call hybrid search. This is actually where you're able to search based on keywords, especially when you're focusing to get facts from the documents, or semantic, when you want the responses to be a little bit more creative. So you can combine hybrid search so that now you get better results for the queries, especially those people working on legal, research, those people working on digital marketing. So this is week one, which I think is very, very interesting. And by the end of that week, which we are hoping that we're able to build a working multi-document RAG system that has a memory, and then in a Streamlit web interface. And then you have combined hybrid searches in such a way that as people are working with that RAG system, they are able to get information based on keyword and semantic retrieval. So that is the first week. And this one, like I've mentioned, it builds on the session that we're going to have today. Now from there, we're going to move to the world of agents, AI agents and automation. So when, like I hope you can see this phrase here, it's very, very interesting, saying that when retrieval is not enough, can we build systems that can think and act autonomously? Okay, and that is what we call agents. So with the agents, they're able to think and act on themselves. So we're going to introduce how to build AI agents with LangChain and LangGraph. I think that session will be very, very well covered with Festus. Festus, I hope you're still there.
Yes, I'm listening.
Yeah, thank you. So you will actually introduce us to this one, where our students will be able to understand what are these agents and how can you build them using LangChain and also LangGraph. I think I forgot to add that one. because you're going to see that this agent can work across many industries. Okay. Apart now, from the introduction, we are going to collaborate on how we can connect this agent to tools, because as they are thinking and acting autonomously, they require some tools. Sometimes an agent wants to do a web search, or an agent wants to get information from a local knowledge. So this fact finding, we are going to need some tools, and that we're going to see how to combine different tools within our agents. And then now we're going to talk about multi-agent system. So a multi-agent system is an agent that can collaborate on doing different tasks autonomously. Okay. For example, if you can have a single agent that is a researcher, so it can research information. Similarly, it can write that information, and similarly, it can fact check the information that it is writing. So these are three-step process. So we have researching information, writing information, and fact checking that information. And it could be done using a multi-agent system. So this independent agent can delegate tasks to each other, and then they normally mirror how professionals team up using what you call AI orchestration. So if let's say you're talking about development, so you need, let's say you need front end, you need back end, you need database, and then you need testing. So you can build a multi-agent system that can collaborate and perform different tasks autonomously, especially for those working on legal, newsrooms, research, and education. And then now, from there, we are now able to automate workflows, okay? In such a way that we can now make this agent take the action in such a way that we build agents that can read emails from different platforms like Gmails. They're able to extract information from databases. They can draft responses, plug teams, and so on and so forth. So I think this automation, normally we have these workflow automation tools available. And I think the most popular one right now is N8. I think these are I don't know why it's not easy to pronounce it, N8N, this one. So it's a workflow AI automation framework, okay? In such a way that you can build AI products that connects to different platforms like Gmails, Teams, CRMs, and so on and so forth. And as we proceed, now it is good we talk about responsible AI, which means that as much as now we are working on documents, we are building these agents, we need to talk about privacy so that AI systems does not misuse our information. You see, AI system can generate usernames and passwords from databases. So we need to talk about privacy. We also need to talk about compliance. Are they really complying with our data protection laws in Kenya? And if possible, are there frameworks that we can use to audit how these systems are operating in the industries? So that now, as much as you're building this system, you're building systems that can cope up with the Kenyan laws, especially if you're building systems that will work on healthcare or finance, legal, or governance. Remember, there are strict laws that govern this kind of industry. And as you're building AI, we need to think about responsible AI that matters to do with privacy, compliance, and audit. So these are very, very important sessions so that now as you're building this agent, they can be verified and used on real industry, because now they are also following the rules and regulation that are there on this industry. So it's a very, very important session, week 2, AI agents and automation. And now week 3 will be very, very more interesting because we are very aware that AI should be applied on different industries. So we'll be having specific sessions for a specific industry. So for example, how can you build an AI that can be used on a legal environment? For example, an AI system that could be used to do contract review, risk flagging, and so on and so forth. AI system in finance, AI systems in healthcare, climate change, energy, and environmental policies, and then also AI systems for education. I think these are projects that Festus has already built in such a way that we have an AI system that acts as an intelligent tutor in such a way that it can teach someone and also assist on curriculum development. So I think Festus, you've done this one, ready? This one, the one we call Jenga AI. If you're still there, are you still there? Okay, so I think we can proceed. And now from there, we'll talk about now deployment, optimization, and a capstone project. But still, we'll be focusing on more AI system on different industry, like how can you build an AI system on a digital marketing space? How can you build an AI system that can work on governance and public sector? And then from there, you can optimize the systems. You can deploy this system from a local production to a real server. And then finally, now we talk about how you can come up with your custom project. So this is actually the roadmap that we have. We might be updating it as we proceed, depending on how the content is and how you're also taking the content. So I think that is the outline. I really needed to mention this one so that at least we have a clear guideline on what to expect. So today, I wanted to introduce RAG. Today, I wanted to introduce RAG. I'm sure you've heard about RAG system. So RAG stands for Retrieval Augmented Generation. So I think I'd mentioned this one earlier, that RAG systems combine two powerful capabilities. So we talk about information retrieval and text generation. So with the information retrieval, we are building AI systems that can retrieve information from different sources, from the different documents. And then after retrieving those information, now it can generate them using the text generation feature we have on large language models. So this is very, very popular in such a way that we don't rely on what the model has learned during training, okay? Instead, with the RAG system, we can allow the model to look for information from different sources, like even from our own documents, at the time that we are asking that question. In such a way that if you have a RAG system, you're able to generate precise responses that have grounded truth, okay? So this is the scenario you're having. Before the model answers your question, it has to go quickly search through a file cabinet of the relevant document where it can get those information. And then from there, after searching, it has to find the most useful pages, read through them, and then gives you the answer based on what you just read. So this is exactly what RAG does. So we have indexing, retrieval, and then we have generation. So I had prepared for you an image, basically because images communicate louder than words. So this is actually an image that clearly demonstrates how a RAG pipeline works. So if you're seeing this image, which I can even share on the chat, we share this image on the chat. I'm sharing it on the chat right away. There you go. Perfect. So I've shared the image on the chat. So if you're talking about RAG pipeline, remember there must be some documents. And these documents here, we extract or we retrieve information from these documents. And then after retrieving this information from documents, we convert them into embeddings. Okay? So the embeddings will be the numerical representation of the information we've captured here. And now those embeddings are stored on something we call a vector database. So we have different types of vector database. The most popular one is Chroma DB. But for today, we want to use Facebook AI Similarity Search. That is what we have been using for this session as our vector database. So if someone asks you, what is a vector database? So a vector database, it's an information, it is a platform that has stored embeddings that we retrieved from different documents here. Okay. Now, users, they will give a query this information. So now I want to get an information. So as a user, I want to query an information. So remember, as you're querying that information, you are querying the information from the vector database. And now, as you do that one, which you are now calling the data retrieval, there's something we call the top K chunks. So these are the most relevant information that has been retrieved from the vector DB based on your query. Okay, based on your query, top K returns the most relevant information. And now this information are now passed to a large language model. I hope you see that one. So that now we get a text generation feature as our response. So we have documents that are stored in a database called a vector DB. You query that information. We now get a top chunk that is passed to the LLM, and then this is your response. So this is the simplest way to understand a RAG pipeline. So we have data indexing, where documents are stored, and then information retrieval, generation. So anyone with a question? Up to there. Anyone with a question? Michael, you have a question? Michael, you have a question? Okay. Yeah, so I was trying to explain the RAG pipeline. I hope you've understood that you must have a document, you must have a vector storage, then there should be a way for you to ask information from that document. Then we are going to get the most relevant ones that we pass to the LLM, and then we generate them as your response. So here, I think now I've explained this one, and I also had mentioned the difference between RAG and fine-tuning. Okay, like where I had mentioned that if you're talking about fine-tuning, it means that you have to do what we call retraining the model with more specific data. And now the process of training a model with more specific data is sometimes very slow. You have to wait. It is expensive because you have to have very powerful computing resources, and also it requires a lot of expertise to fine-tune a model. So with the RAG, you don't need to retrain a model. Basically, you just need to make your model know about your document. And then now from the document, they are stored in a vector database and then retrieved at a query time. So no retraining needed, which means that no GPU required remember GPU are required, especially when you're doing training, and then now you're able to get model with up-to-date data without touching the model. So a lot of industry can apply this tool. I think I'd mentioned this one. So for you to build this RAG system, you must have the following requirements. I think this one I'd already mentioned. And at least you need to have a document that you can retrieve. You need to have a document that you can retrieve. So just think about any document that you want to pass to an AI model, and then we can now query information based on that document. So think about a single one today, okay? Think about a single document that you might want to use so that you pass it on your system and then query information. So I don't know, which document can you use? Which document can you work with? I was thinking about which document can we apply before you now go to the setup. Anyone with a suggestion? Festus, do you have a suggestion of a document we can download and retrieve information? On the previous class, yes?
Sorry, a document that we can download, then use it for
RAG, yeah, that we can now query.
RAG.
Like, for example, on the different session, I had used the Kenya Kwanza Manifesto so that we are able to ask questions from that document. Any document that we can think about today, a different one?
No, I have none at the moment, but I can check. Let me try and search.
Okay, let's think about let's think about Vision 2030 agenda. The Vision 2030 agenda. Okay, I think let's just be more specific. Sustainable development goals, yes. So there is a document. Let's have it as a PDF. So if you have internet right now, I was thinking about a document we can use today, and I think we can try Sustainable Development Agenda. I don't know whether that's okay with you. This document, because this document highlights the 17 development goals according to the United Nations. So they have no poverty, zero hunger. Yeah, so these are development goals. I don't know whether it would work, but you can think about any document that you want. It has 19 pages and a total of 17. I don't know, there are 17. Yeah, normally there are 17 sustainable development goals. So just go ahead and download this document. Just go ahead and download this document. I can have it on my desktop. So here. So we have a document, like we have a knowledge base. So now I can have a RAG system that will allow more people to understand this document based on the queries. I can even ask, give me the fifth sustainable development goal. And very, very quickly it can go there, retrieve the objective of the fifth sustainable development goals. I'm sure I hope you are very aware about these goals. So these are the 17 goals that were passed by the United Nations in trying to ensure that we have a better world. So we have a better world where there is no poverty, there is zero hunger, good health, we have quality education. Yeah, so these are the goals. I've downloaded the document. So make sure you have a document that we can use. I think I'll go with this one. Now, from there, we need to have our setup right. We need to have our setup right. And now for us to build this RAG system, we need some more libraries. So remember, in the previous one, where we were building the assistants, we had installed 2 libraries. So we had installed LangChain Ollama and LangChain Core. So this is the LangChain Core. This is the LangChain Core. Because if you check the code that we are going to develop today, there is a LangChain Core where we have LangChain Text Splitter, we have LangChain or LangChain Core, we have prompt, we have runnables, we have output. And also we need today to have, sorry, I hope I'm not misleading. So today we want to install 2 more libraries, not even 2 more, some more libraries that we're going to use today. So you need to have LangChain community and PyPDF. And I think they have explained to you why we need these libraries. For instance, if you need LangChain community so that now you are able to connect with more documents like PDF, words, so that now and then PyPDF allows you to read information from this document. So if you didn't install this one, make sure you have it. If you didn't install this one, make sure you have it. Where do you install them? On the command prompt. So on your command prompt here, make sure you are installing all these libraries that are needed. That one. So LangChain, LangChain community and PyPDF. So these are needed. And then also you need to install Facebook AI Similarity Search CPU. So this would act as your vector database today, okay? Because it will store your document embeddings and let you search through them instantly. So you need to have this library. If you don't have this one installed, please refer to your terminal, install this one. Because based on the diagram here, we need a vector storage here. So that as we pass this document, they can be stored here and they allow us to query information from that DB. So for today, we are working with Facebook AI Similarity Search. So if you don't have it, make sure you have installed it on your system. So to install, the one we're using is pip install Facebook AI Similarity Search. I hope you have that one installed. In case you're left out, please feel free to ask, or you can pass the question on the chat. Yeah. Now, the next thing we want to install is LangChain Text Splitters. This will actually make our work easier, especially when you're working with more documents tomorrow, because LangChain Text Splitters break large document into smaller chunks. And then we also need Ollama. So we already have this one. So if you didn't install this one, ensure you have it, because LangChain Ollama connects your Python code to the locally running Ollama model. So remember, we have models running on Ollama here. So with the LangChain Ollama, we have access to these models running on Ollama. So if you don't have LangChain Ollama, there is no way you are able to access these models on your code. So that's why you need to have LangChain Ollama installed. But remember, we had also installed it previously. Now from there, I think the setup is done. So anyone who had a challenge, because this is the most critical part, the setup. Anyone who got a challenge with the setups and installation? Anyone? Kindly. Before now we proceed to the development phase. Anyone who got a challenge? Anyone who got a challenge? Okay, so we're going to know whether the installation was a success or not, based depending on the whether the code would work or not. Okay. So I want us to create a new folder. Let's just work with a new folder today because it's a new week. Let's just work with a new folder. Let me have this one here now. So create a new folder. Create a new folder. We can now call it RAG. Let's call it single document RAG system. So remember, this is a single document RAG system. Why is that one the case? Because it can only work with a single document. And then tomorrow we are going to check on multi-document RAG systems. So if that is the case, remember there is a document we have already downloaded. So I want you to go and copy that document. So let me copy that document. I think it's on my downloads. Where's the document? I can't find mine. Let me confirm where it is. So remember, there is a document you have downloaded. So for example, myself, I had downloaded the Sustainable Development Goals. So now I want to, I think mine is on the desktop. Yeah, it's on the desktop. So I was trying to locate that document where it was saved. So it is here. Can you see it is here? So make sure that this document, it is inside that folder, because that is our knowledge base. That is our knowledge base. And then tomorrow, we are going to think about how we can have multiple documents, okay? How we can have multiple documents. So make sure the document is in the folder that you've created. So the folder, I've named it Single Document RAG System. So that is step 2. We have a folder. The folder has our document. Now from there, we need now to open this folder on a VS Code. So we need to open it on a VS Code. So make sure you have VS Code running and then locate the files. Open the folder. On your desktop, we've called it Single Document RAG System. Okay, so you go to the file, you open a folder, and then you locate your Single Document RAG System. Then you're going to select that document. So you have a very clean work where there is a folder here. So there is a folder here, Single Document RAG System. And then inside that folder, we have our knowledge base, that one. So this is the document that we are going to get information from. Now, we need a Python file to implement the Single Document RAG System. So create a file here. You can call it single underscore RAG. Just call it single document. I think let's just be specific. Single document underscore RAG dot Python. So I've created a document called single document RAG dot Python. And one thing that you have to ensure is that your Python file and your document should be in the same location on your folder. Yeah, so anyone with a challenge up to there, I can happily repeat that process. Anyone with a challenge up to there? So we have created a folder called Single Document RAG System on our desktop. This folder, we copied and pasted the document as our knowledge base. And then from there, we have created a Python file. You can give it any name, doesn't matter. But I've called it the Python file, sorry, single_document_rag.python. So it's a Python file that we want to implement our RAG system. Anyone with a question up to there? So I think we can now start on our development. So let's go very fast as we are explaining the process. Please, if you get a challenge, let me know in the chat. So the first thing is to confirm whether your installation was okay. Your installation was right. So I want you to copy the libraries that we need. The libraries that we need. I want you to copy the libraries that we need, go to your VS Code, and then you paste them here. I don't want to generate today, just want to paste because of time. So how do you know that you have all the required libraries? Ensure that there is no any yellow underline to any particular library. So I think we can give it a comment. Good to do that one. Control question mark. Here we are now importing necessary libraries. So we need LangChain community to work with the document. We need text splitters so that we're able to break down documents, content. We need Ollama so that we're able to work with chat Ollama models. Specifically, we're going to work with Llama 3.2 model from chat Ollama. Yeah, so these are what we need. So kindly let me know if you see something like this one. Let's say I import a library like, which library I don't have? Scikit-learn. So you see, I have not installed Scikit-learn. I have not installed Scikit-learn. So if you see this yellow underline, already it means that not Scikit-learn, but sklearn. Sorry. sklearn, not Scikit-learn. I don't know whether I have it. Yes, I don't have sklearn. So if you don't have a library, automatically you'll know if you see the yellow underlines. This one clearly showcases that you don't have this library installed into your system. So I want you to check whether out of all the libraries we have installed here, there is anyone with a yellow underline. If there is one, make sure to do the reinstallation again for that library. So that is very, very important. And this is clearly showing us that all the installation we did on the terminal was successful. And that is the biggest part, because if you have all the tools, let's say today you want to build a house and you have all the tools needed, then building a house becomes so easy, unless now there is a tool you don't have. Similarly here, we want to build a RAG system and we have all the libraries we need properly installed into the system. Now from there is configuration. So we are now configuring tools that we are going to work with. So I want you to copy this line. I want you to copy this line. Copy this line. Sorry. And then we paste it here. Yes, here. So in our configurations, our model is Llama 3.2. So you know why you need the model. But now something else we don't have is the embedding model. So it's the embedding model. So embedding model will be used to convert the chunks into embeddings. Okay, so if you don't have this one installed, you can go to the terminal and pull that one. I think it has been explained on the document. Let me just confirm where you can pull it. Yeah, here. So if you don't have this embedding model, just go to your terminal and pass this command here. Because this embedding model called Nomic Embed Text, it is part of the Ollama models. So therefore, if you don't have it right now, just go to your terminal or go to your command prompt here and paste this code, which is in step 4. As we are creating the embeddings, we will need that model. So that's why I want you to have it before we reach step 4. It will be very, very easy for us to now do the implementation if you have all the setup that is required. So make sure you go to your command prompt or your Windows PowerShell. I think I did the same before, just confirming where I did it. I think I did the same command. So you go to the terminal, you pull Nomic Embed Text model. So we want that model because it is lightweight and we want to use it to embed our information. So this is where I did it. I don't know how long it took, but I think it worked. It took around 2 to 3 minutes to pull that model. So you need to pull the model by running this command on your command prompt or on your terminal if you're working with a Linux or Mac. You need to have this one. Okay, you need to have it because even on the diagram there is a process where we do embedding. When we have the document, all this content must be converted into embeddings so that now we store them on a vector database. And now for us to have this process successfully, that's why we need the model. So make sure you have it. And if you have it, it means that your configuration is successful. You have a Llama 3.2 model pulled. We had pulled this one earlier. If you don't have it, just say Ollama pull Llama 3.2. In case you missed those lessons, I'm doing this one for those who are not there. If you don't have Llama 3.2, this is how we did it. You just say Ollama pull Llama 3.2 LLM. So you need to have it. So it is our large language model. It is our LLM. So then the setup is done. So we have the model itself. We have the embedding model. And then we have the path that will be created to store our vector embeddings. So remember, after doing the embeddings, all the embeddings will be stored on this folder called Facebook AI Similarity Search DB. So this is the path. This is the location where all the embeddings will be stored. Let's go to the next part because of time. So I hope you're together up to there. Feel free to ask a question in case you have one. In case you have one. Now, step 3 in our in the process is that process. Step 3. Where's that document? It is here. Perfect. Now, I think we are done the setup. So step 2 now, I think everything has been explained here. All the explanation for the configuration are done here. So if you want more clarification, you can still revisit the document that I shared on the group. Okay. Now let's load our document. Let's load our document. So today is a single document that we are loading, and we're using this command. Then we're going to explain it. Just copy that one. Very, very simple. And then you have it here. Paste it here. Now, what is happening? I think I should remove this one. I should remove this one. Let's first make it empty. Now, PyPDF loader from LangChain community, it is used to load the documents that you're talking about. I don't know what's happening. Yes. I just want to make it empty for now. So using PDF loader, we're able to load the document, and the document will be loaded using this method. And then we're even able to print the number of pages in that document. Okay. So I think we're up to there. We can run our code. So what I want you to do here, I want you to copy the relative path of this document. So I want you to copy the relative path of this document. So right click, and then we copy the relative path. So remember, don't copy the path, but the relative one. And then you paste it here. Like that one. So I want you to run this one and see whether it's working. So up to this point, we want to see whether the importation were okay, the setup is okay, the document has been loaded successfully. So let's run this one up to here before we proceed. So right click, run Python in the terminal, give it a wait, and then we confirm. So it takes time depending on the size of the document you have. And I hope you can see that everything is working well, because the response I'm getting here is that we have loaded a document that is comprising of 19 pages. So the document we have loaded into our Facebook AI similarity search vector is of 19 pages, which you can even confirm with the one we downloaded. If it is 19 pages, then indeed, that is the document that we want to use as our knowledge base. So let me confirm how many pages. Yes, they are 19. So if you confirm here, there were 19 pages, and specifically this document has been loaded into our project. So if up to there it has worked, then it means that the remaining part is very, very easy, because now we need now to split. So using text splitter, we can now split the document into smaller chunks before converting them into embeddings. So this makes our work easier. So remember, each page will be represented as a chunk. Okay? Yeah, okay. So let's do that one. I want to copy this code. Please make sure you do the same. So the document is split into smaller chunks. Press that one here, right here. Remember, I've not completed it. I just want to copy the exact one. So therefore, then we have it here. Can have it right here. Yeah, so that is the process. So there is a text splitter that we are calling recursive character text splitter. We are going to split the content into chunk of 1,000 characters with an overlap of 200, ensuring that we don't lose the original content for the document. And then now we have created the chunks. So let's see how many chunks we have. Run Python, the terminal. Let's see how many chunks we have. So far we have 52 chunks from the 19-page document. Yeah, sorry for that one. So there was some background noise that I was trying to check. But now we have loaded a 19-page document. Out of the 19-page document, we have a total of 52 chunks. So we've broken down that document into 52 chunks that we are now able to process into a numerical embedding. Okay. So in the next step, because of time. So I think everything is being explained here, why we need an overlap of 200 characters, and then we can split the document into 1,000 characters and so on and so forth. So now we need to create an embedding model. So remember, the chunks can be now converted into an embedding model, into an embedding, so that now we store them in a vector database. And because already we had pulled this model from Ollama, we are now able to build our embedding model here. So I think I can copy this part where we are creating the embedding model. Then we are passing it here, like that one. Then I had given you an explanation that in future, especially in most RAG systems, they work with Chroma, okay? Yeah, so our embedding model is the embedding model that we configured. The embeddings will be stored on a vector store, which is actually Facebook AI similarity search from documents. And then we are going to pass the document splits and the embedding. And then we save it locally. We save it locally into the path. So remember, we are going to save all this embedding into the path that we passed. So I want to see something very interesting that will happen when we run this code up to here. So a folder will be created with all these embeddings. So let me just run this one on the terminal. And now, as we are waiting for that one, there is a folder that will be created that contains the embedding. Now it is embedding all the 52 chunks. All the 52 chunks are being embedded. And then now the result here is that the vector database has been created and saved, and this is what we have. So our vector database have the index and the model. So this is the model, and this is the index, okay? So now we have a knowledge base. So now the next process is retrieval. The next process is retrieval. We want to query information from this storage here, okay? So that should be now the next phase. Sorry for that one. So we have some embeddings stored locally on our machine. The explanation is here. We are being told that this is the heart of RAG because the model that we pulled, this one, has converted into each text chunk into a vector. And if you are asked, what is a vector? A vector is numbers that represent the meaning of a text. So now the next one is to set up the prompt because we want to query information from the vector storage according to this diagram. So right now, we have a vector storage. So we want to do a query. Now, for us to query information, we need to talk about prompts and prompt engineering principles. And that is the next phase. So we are setting up our language model that we are going to prompt, and then the prompt template. I think I can copy this one. I hope I'm doing the right thing. So copy this one. Copy this one. So these are prompt templates, and have it here. That's that one. So here, I hope you're seeing that one. I think I can give it a space. Now, We have initialized our model as the model we had on configuration, Llama 3.2. We have set the temperature to 0.2 because we want to deal with facts. So we want our responses to be as factual as possible. And then after that one, we need to set up the retriever, a way to get to generate the information from the model. And I hope you're seeing that our retriever from the vector store is getting the top K of 3. So we are focusing on the 3 most relevant chunks, okay? And then we can give it now the prompt template. So this is actually where most people define exactly what you want to do with the document. Like in the prompt template here, which you are saying chat prompt template, you are asking the model to answer question based only on the context. So we are going to provide the context, and then it will be used to answer the questions from the user, okay? So in the next phase, is to now build the chain. So we are going to build the chain. So we are going to build the chain. And I think this should be the final step. So we are going to build the chain. Here you go. Here. So we have it here. So what's happening here is that we have a function here that will go through the top 3 chunks that we've retrieved as it's generating the content. Then we build a chain. So remember, the chain is in this manner. I think we had talked about the chain. It's the sequence of steps that our LLM would follow. So chains refers to the sequence of steps that our LLM would follow to give the question. So the first thing our model need to have is the context. And the context, it is based on the information we have retrieved. I hope you've seen that one. So the context refers to the information we have retrieved. Now, based on the information we have retrieved here, which is the context, the next thing on the chain is the prompt. Now, what is the user query? It is the prompt. Now, from the prompt, we go to LLM that gives the response. And then this string output parser ensures that we give our response in a human readable language, which is a string. So we are talking about a string output. So this is our chain. So we start with the context, the document we have retrieved, we go to the prompt, the LLM, and then the output. And now from there, the user would give a question. So yeah, I want to leave it blank because we are going to ask the questions here. We're going to ask our question there. And then the answer we are getting will be based on the question we passed. And then this question we are waiting for here is this one here. It's this one here. Then we're going to get the answer. And then to get the answer, it is always important. So at this point, we are now trying to get the sources of these answers. And then finally, I think there's our last line we had missed before we run this code. This one here. I think we can copy this one and pass it here finally. Yeah, so we can pass this one here, like that one. So this is the entire RAG pipeline that we need to have. So now we just need to pass a question and then we wait for the answer. So let's do that one. I think I can ask, what is the agenda number 5? What is the agenda number 5 in sustainable development, as sustainable development goals? Yeah, so what is the agenda number 5 in the Sustainable Development Goals? So we want to see whether our model is able to go through the document, get the relevant chunks, achieve information based on this query. Let's do that one. And then also give us an evidence of the same. So now that is what I'm waiting for here. That's what I'm waiting for here. So vector has been saved again here. Then now it's the process of retrieving information so that at the end of the day, we get the answer that is based on this question. Yeah, so it's actually saying that according to the document that you provided, the agenda number 5 in Sustainable Development Goal is to achieve gender equity and empower all women and girls, according to the document that we provided. So maybe it's good we confirm. It's good we confirm whether exactly that is the 5th agenda of the SDG goals. That is 6. So this is the 5th one. And I hope you can see that it actually went exactly to the 5th document, and it actually received this information that the 5th agenda of SDG is to achieve gender equality and empower all women and girls. So now we have a model that people are able to use to work with documents. And then as it is generating the document, it is giving us the exact source of that information. Like it is saying that information, I got it on page 4, which you can even go and confirm. Page 4. This is page number. If you even check, this should be page number 4. Is it 4 or 5? They don't have the numbers. So I think it should be page 4 to 5. Yes. Yes, page 5. To look at it here, page 5 out of 19, it is where we are getting that information. So it looks like it is working, and now we're able to ask even more queries, like what another one? Which agenda focuses on climate change? Yeah, that one. Let's try this one finally. So anyone now with a question to do with RAG systems? Anyone with a question to do with RAG systems? But basically, that is the process of coming up with a RAG pipeline, where basically we need to mind about the knowledge you have, which is the document. From the document, you need to mind about embeddings, and then you need to mind about how the information will be retrieved and then generated back to the user. So which agenda focuses on climate action, and what are the specific targets related to that one? And I can see it is actually giving us answers exactly based on that document. So I want a question from anyone or a suggestion. A question or a suggestion? Anyone who got a challenge? So this was our question. So it is actually saying that goal 13 takes action to combat climate change and its impact. Yeah, so anyone with a question? Yes, anyone with a question up to there? Anyone with a question? Anyone who got a challenge? They can pick one or two. Alex, how was it? Alex or Fatuma, you have a question?
No, I've managed to do it.
Oh, okay. Okay. So I think with that one, we can call it a day. So basically tomorrow we'll talk about how to have now a multi-document RAG system. So instead of just relying on a single document, here we can now provide more knowledge base so that now we get more credible sources of information for our RAG system. So I wish to stop there for today. In case of those who joined late, I've recorded the session. I'm going to share the session recording exactly after the call. So with that one, enjoy your night. Let's meet tomorrow. Work on any part that maybe didn't work, including the installation, so that now tomorrow you are ready for a multi-document RAG system. Enjoy your night. Bye-bye.